Hey there, today we'll be going on to this problem that is from the graph playlist of Leetcode, that is 417 Pacific Atlantic Water Flow. And all the other days have already been uploaded. Please do check it out and follow this for Leetcode specific graph problems that are present here. So the question statement is actually pretty big. I'll be explaining you in a simpler term. Okay, so let's get on to this problem. So they have said you have been given a matrix, and the top and the left part constitute of Pacific Ocean, and the right and the bottom part constitute of Atlantic Ocean. The water will only flow if and only if the values that are coming on is in increasing order. And when so, see, let's just say that you have something like this. So water from Pacific will flow from here. Okay, this is fine. This is totally fine. Pacific, because these are all boundary elements, right? So all these guys will be getting the Pacific Ocean's water. Fine. And all of these guys that are here will get Atlantic Ocean's water at first. Okay. So these are the parts that are getting Atlantic. So you can see that some cells are there which are also getting Pacific, and some cells are also getting Atlantic Ocean's water, right? That is this cell right here, that is this 5, it is getting Atlantic as well as Pacific. And this cell right here, that is this one, this cell and this cell are getting both Pacific and Atlantic water, right? So you just need to return those cells which are getting both the ocean's water, right? So this is this problem in simpler manner. So how we will do it, and let's understand the question more better before getting on to how do we do it. So they have said that Atlantic Ocean's water, it starts from flowing here, right? It will flow and it will flow, but there is a condition to it. It will only flow until the value previous to it is greater. That means it is an increasing order sequence. Let's understand this better. If you see this grid right here, this grid, right, this grid will get what water, Pacific or Atlantic? It will get both. Why so? Let's see. As I said, coming on to increasing order, 1, 3 and 5. What is this? If you just see it in this way, it is increasing. Otherwise, you could consider this as decreasing. That will be much easier for you, right? So 5, 3 and 1. If you see, the values are in decreasing order, right? 5, 3 and 1. That means water from Atlantic can go till here. That is what you need to know. And that is how we will do the question as well. Okay, but can the Atlantic Ocean's water reach up till this 4? Obviously not. See, this part is increasing or whatever decreasing, let's say from 531, this is a decreasing sequence. But is 4531 a decreasing sequence? No. And what do I mean by decreasing sequence? That means 4 should be greater than 5. Is it? No. But if you see here, 5 is greater than 3, 3 is greater than 1. This is actually following the sequence, right? So if this is actually following the sequence, that means Atlantic water can go up till here, this 5 cell. Fine, this is done. Now the Pacific. Now let's see, the Pacific water can go till where? 2, 4 and 5. If you carefully see it, this is actually a decreasing sequence. That means 5 is greater than 4 and 4 is greater than 2. This is a decreasing sequence that we can get here. Okay, so Pacific reached there and Atlantic reached till where? Atlantic water also reached till this guy right here, that is 5. Now if you see, there is an overlapping part. 5 is getting water from Atlantic and Pacific as well. Okay, this part is getting water from both. So this is the cell that you need to return. Fine. And they have also said that we can have values greater than or equals to. That means this part right here, if you see, values are equal. Okay, so the Atlantic water can go there. Fine. So it can either be decreasing in this manner or it can be equal also. So these are the two conditions when we can have a water flow from some particular ocean. Fine. So I hope the question statement is clear to you now. Okay, and now let's understand how we will do it. So if you have been following this playlist, we use DFS or BFS for simple traversal, right? We are going to use those traversal as well here. Now, if we see, a approach to this problem could be something like, first of all, we will try to fill all the cells with Atlantic water and all the cells with Atlantic water from bottom. What do I mean by that? That is, this is ocean, right? From here, water will try to come, water will come, right? And it will try to fill all the cells to which it can go at max. So what do we see? We see 5. Okay, 5 is filled with Atlantic water. Can it go to this? Obviously not, because this cell has to be greater than or equals to the previous one. Then only the water can flow into this. That means if we had something here like 7, then 7 is greater than or equals to the previous cell. That means we can fill water there. Otherwise, we cannot. Now, coming on to this cell, that is, it will go to 4. Now, 4 is greater than or equals to 4. That is why it can go here. Now, again, this total will be filled with Atlantic. Okay, I'll just mark it with something other than that. That is, let's just mark it with green. These are completely filled with the Atlantic water. Fine, this hole is completely filled with Atlantic. Now coming on to this will be filled, and only till this only. Why so? Because again, 4 is less than or equals to 5. It is not greater than or equals to 5, right? So that is why we cannot fill it here. Again, this will be filled. Now this part, see, 4 was not previously filled from this side. Why? Because 4 was less than 5. But if we see, 4 is greater than 2. From this side also water is coming, right? So now this part will also be filled. So this is done. Now again water will come from this side. So this part also will be filled. Now coming on to this cell, water will start to flow from here 1, 7. Now it will stop till 7 only, and this part will also be filled. So basically this whole thing is filled with Atlantic water. Okay, now this thing is done. Now we will try to flood all the Pacific Ocean water into all the cells that can reach. So from here, Pacific Ocean comes. So Pacific Ocean, from here, when it comes, it can fill this one. Obviously, again, 5 is greater than or equals to 4. It will fill this cell also. I think it is getting a little messy. So I'll just erase that part, and I'll just now only focus on the Pacific Ocean part. So this part will be totally filled. Now coming on to this part will be filled, right? This part will be totally filled. This part also will be filled. This part will be filled, and also this part will be filled completely by Pacific Ocean. Now, if we try to see that we have gotten Pacific Ocean's water till here, after that we come on to this cell, we fill it. Why so? Because this is the first cell. Eventually, it will be getting filled. Obviously, this is done. Now, this part will also get filled, and this part will also get filled, and this part will also get filled. Why so? Because if you carefully see it, it is in decreasing order, right? Anything which is in decreasing order can be filled by Pacific Ocean or Atlantic Ocean respectively. Okay, okay, and I have missed actually this part right here. This whole thing will also be filled. I've actually missed it. And coming on to these, whenever you see a decreasing from either right or from bottom, you just fill it. That is the only thing that you need to do. You see a decreasing sequence, you do it. You see a decreasing sequence, just do it. This is the whole thing that will be filled by the Pacific part. And actually this will not be filled. That is, this one will not be filled. It will just limit itself to this. And why so? Because if you see, is this a decreasing sequence 5 and 1? Obviously not, right? It cannot fill from the left side. That is why this will not be filled. And all the Pacific part that was filled previously from this, that is from this and this part and this part as well, will eventually get a similar cell which has both the type of water. Okay, and you need to return those cells only. Okay, so this is the actual part where you need to take care of. And now the whole explanation part has been done. You just need to do a DFS. In more simpler words, what you need to do is just do a DFS from Pacific Ocean. Okay, and what is Pacific Ocean? It is actually the upper row and the left row, and try to fill all the rows. And then do a DFS from Atlantic Ocean, that is from the right and from the down or bottom. Okay, and whenever you get both of these guys filling a particular cell which is similar, you just return those cells in a vector or an array, whichever you like to call it. Okay, so now let's get on to the code part. So code is very simple. It might look very lengthy, but it is actually very simple. It's not that hard. What we need to do at first is we need to create two visited array. Why so? Let's see. Since if we try to do it in one vector, it can be done, but it will get a lot messier. So what we can do is we can create two vectors. And what are these vectors saying? This vector will store all the Pacific water and this will store all the Atlantic. Okay. So from Pacific, if we start, these cells will be filled only. And if we start from the Atlantic part, which cells will be filled? From the right, everything will be filled. Okay. So what is common in between both of them? This region is common, right? This region is common, and that is what we will return. So at the end of the day, we'll just traverse in the matrix and we'll see whichever guy is filled in both of them or marked visited in both of them, we will just return those cells. Okay, so that is why we have taken two visited array. And at first, what do we do? First we do the Pacific one, that is the Pacific. So this part is taking care, this ig that we have, you just see here that this is the zeroth row, and zeroth row has which one? Having Pacific. Okay, it is having first Pacific, this one. It will eventually also have Atlantic, which is done later on in the code. Okay, but first I have done it with Pacific. So first we will fill it with Pacific, then we'll fill it with Atlantic, and thereafter we are doing the left and the right cell filling. Okay, so first we fill it with Pacific and Atlantic water, that is from this one, and then we eventually go to the left, right, and the bottom part. Okay, now coming on to the DFS part, what do we do? The DFS part says that it is a simple DFS right here. The only thing that you need to take care of here is the previous values and why this previous value has been taken here. See, as I said, there was a condition that if the values that we have, that is here, this is here, right? And if we go on to some cell, I'll explain to you this in a much better way. Let's just consider this cell. You were here, fine. Now DFS says what? You can go to left, right, down, or bottom. Here how many options do you have? You can go left, up, down, and right. Right you cannot go. Why so? Because it is out of the bound. You cannot go into the ocean, right? You can only go into the matrix. Will you go to the up? Yes, you can go up. Why so? Because where you are going, the value or whatever the number that is present there is greater than your previous value that you are coming from. Okay, so that is the reason we take previous value. So whenever we are reaching to a new cell, we will just compare it with the previous value. So where I'm reaching to a new cell with a value 3. Is the value 3 that we have, is it greater than or equals to where I'm coming from? I'm coming from where? From 1. So is it true? Yes, it is true. That means we can go here. Okay, and we will mark it. And from here, we'll again do a DFS again from left, right, up, down, and bottom. And also we are marking it from where we are coming as visited also. Okay, so we are maintaining both the things right here. So this is the part where this previous comes into play, and both these DFS have exactly the similar code. Okay, so you don't need to worry about that. If you understand one DFS, you'll understand both the DFS. So this is the DFS function that is being written here. After that, what do we do? This is the outer bound condition check that we are doing from day one. This is pretty evident. Now only this thing is new here, that is whenever I'm coming on to some new index, is the value lesser than the previous one? If it is, we cannot actually jump onto that. But if the value that we are coming to is greater than from where we are coming, that is why this return statement is written there. This is only the main part that you need to understand. Other than this, everything is similar to what we have done so far. So this condition is doing what? Let's just say you were at 4 first and you jumped on to 3. That is the left cell, let's say. So can that value be lesser? Obviously not. Since I said it should be in decreasing order. That means wherever you are jumping, the value should be greater from where you are jumping right now. Okay, so this is the part where you jumped, and this is the part where you were previously, so you cannot do this. So that is why we'll just return it, return from there. We cannot jump there. Okay, but if where I'm jumping, the new cell has a value which is greater than from where I jumped, if it is, then we can surely move forward, and that is a safe cell. That means we jump onto it. So that is why we just do a visited is equals to 1, and we do a DFS again onto left, right, down, and bottom. And since I have already jumped from left, what will I do? I'll not jump onto that again. So that is why I'm marking also this part as visited. Okay, and this DFS1 that I've written, it is exactly similar. I've just copy pasted the same code twice. Okay, so it is nothing different other than that. So only thing you need to do after that is you need to just check if both the values have been visited. You just push it into a answer vector, and that is what you are returning at the end of the day. Okay, and that is it for this one. The code will be in the description. If you still have any doubt, please do ask me in the comment. I'll be replying to it surely. Okay, and yeah, thank you for watching. If you are liking this playlist and if you understood this video, please do like and subscribe. And yeah,